Welcome back. We hope you all enjoyed your breakout sessions. Up next on today's agenda is a fan favorite, our special sneak peek session. During this session, our R&D team will provide a behind the curtain of some of our upcoming features. This is now the third time that Onshape has done this, and we're really excited to show you all of the things that we're working on for 2023. So without further ado, let me introduce the man of the hour, Senior Vice President of R&D for Onshape, Vajrang Parvate.
Hello everyone, and welcome. As you might know, we here at Onshape have a new product release every 3 weeks, full of enhancements and improvements. We don't often talk about future plans, but Onshape Live gives us a unique opportunity to show you all a sneak peek of what we're working on and the direction we are headed over the coming year. I'll be joined by members of Onshape's R&D, as well as the user experience and technical services team to show you some of these exciting projects. And when we're done, we'll get to as many questions as time permits. To ask your questions, please go ahead and enter them in the Q&A area at any time. Now, let's begin with Cam Studio, the newest and most anticipated addition to the Onshape product family this year. Please welcome Jake Delano from our technical services team to show us some of the highlights of what Cam Studio is capable of. Take it away, Jake.
Thanks, Vajrang. I'm Jake Delano, here to bring you Cam Studio. Today, we'll be demoing this inside of Cloud Milling, which is the backbone of Cam Studio as we're putting the finishing touches on the product prior to its release. All the functionality that you see will be the same, plus more as what gets released into Onshape in the near future. The only thing that'll change is the UI a little bit, so it looks more like Onshape. When Cam Studio is released, you'll get functionality for 2.5, 3, 4, 3+2, and simultaneous 5-axis machining. This is all done in a state-of-the-art cloud-native environment that uses cloud compute to get your job done. We'll take a look at this 3-axis machine part right here. This is a motorcycle bracket, and inside of the Cam project, we can see the job elements such as the part, the stock, and the fixture. On the left side of the screen, we have the job setup, the tools used to create this job, and the tool paths that are used to machine the part. These tool paths that you have been pre-populated for time considerations. Now, when I open up this roughing operation that's been created already, it gives you an idea of the depth of functionality that's inside this product. There are multiple layers of parameters that can be set in these toolpath settings to create a high-quality, professionally machined part. When you do create these toolpaths, they're calculated according to the values that you've applied and can be seen in the graphics area. To visualize your tool and your toolpath, check the box next to the operation to see it pop up on top of the model. Additionally, you can preview the in-process stock model after each operation by selecting the stock icon to the right side of the job tree. This shows areas that weren't machined during the roughing, giving a clear visual as to where remachining needs to be applied. There are multiple levels of verification, all computed through the cloud for validating the correctness of the toolpath that you're creating. The first level of verification is backplotting. Backplotting allows you to see the movements of the tool to check for the proper approach, clearance, and depth of cut. When backplotting, you have the option to edit the speed at which the operation happens, along with being able to pause and rewind the backplot. To take it one step further, we have the verify option. With the verify option, you're able to see each cut being made to the current stock model and the material that's removed during that given operation. This helps to understand how much the tool is engaging into the material, depths of the cut, and if the tool or holder comes in contact with the stock. As with backplotting, you also have playback controls for the verification process. Now, let's take a look at another part. As with the previous part, the tooling operations have been set up already. The difference this time, though, is that axis parameters have been defined inside of some of the toolpaths where rotation is required. Cam Studio will be able to support the most complex types of machining available today, right from its initial release. Here, you can see a simultaneous 5-axis machine mask. In addition to backplotting and verifying, the deepest level of verification in Cam Studio is the ability to simulate machine operations in context of the actual machine that you'll be using. When the simulation loads, you'll be notified if there are any collisions in your toolpath right from the get-go. When we start the simulation, we can see how the work table moves inside the machine. Now, this is normally an extremely resource-intensive operation to do on a local computer. Thanks to cloud computing with Cam Studio, simulations can be run in the cloud for optimal performance and validation. As this is happening, you're able to toggle the machine on and off for a closer look at the machining table and work components. You can also toggle stock, tools, and your workpiece. The simulations that you're able to run inside of Onshape's Cam Studio are ways to stop catastrophic failures from occurring on a physical machine. It'll make note if there are any collisions, and you can go back and make the necessary adjustments if need be to the toolpath operation. This helps save thousands of dollars that would go into having to repair your machine if you were to collide it in real life. This is just some of the functionality included inside of Cam Studio. You'll also be able to utilize version management for all of your CAM projects, branch and merge to try alternative approaches, collaborate with others, run multiple jobs at the same time in different tabs in the browser, and much more. Now back to you, Vajrang.
Thank you, Jake. There is a lot to unpack there, so if you'd like more details about Cam Studio and would like to see it in more depth, Jake also hosted a breakout session earlier today. The recordings of that session and all others will be available on the Onshape Live website shortly. More and more of you are using Onshape to build ever larger and complex designs, and it's very important that you can easily sort, filter, and locate your components correctly, and get to the right version of your Onshape document quickly. Pete Yodis from our user experience and product definition team is up next to demonstrate some of the enhancements in this area, including product structure view. Over to you, Pete.
Hello, everyone. I work closely with the R&D teams to bring about new features that better handle your design and information challenges. As many of you know, Onshape uses documents as the core unit of storage and sharing. Documents are a great solution for flexible in-process design and branching to explore options. Of course, users also love our multiple document tab approach. These tools are powerful and leave lots of useful data, but challenges remain for companies to easily consume the most relevant information from a network of documents, which are often very intertwined and complicated over time. Traditional search is a solution that can be used, and while this is certainly a very powerful tool in the user's hands, we think we can provide a superior landing point, particularly when users don't know the terms to search on that would provide accurate results. This is often the scenario for employees of a company new to a design or new to the company. In some systems, those employees need to be familiar with the data in order to be efficient in finding the right information, which is a bit of a problem. As a solution to these challenges, we've been working hard to offer a list and structure view of your most relevant company information. In this demonstration, I'll be spending most of my time on the landing page. I'll navigate into a folder here. You can see we have offered new toggles for how you can view your data. The document view toggle is active and is the view you are currently familiar with. This folder certainly has many documents within it, not to mention all the tabs, branches, versions, parts, assemblies, and drawings within these documents. The list view option is immediately to the right of the current document view. A structure view immediately to the right of the list view. More on structure view in a minute. When I click on list view within this folder, I'm immediately provided with a list of components. Moving to the right of the view toggles, we can see a state filter. By default, the state filter is set to latest revisions. However, you can see a pending option as well. The next drop down over is a type filter, which defaults to showing parts, assemblies, and drawings. For our example here, I will just select assemblies, and we can see the results below adjust. The view now is providing all the assemblies at their latest revisions in all the documents within this folder. Moving to the right again, you can see a sampling of our plans to offer additional filters to pare this view down even further and help you narrow in on your desired results. Inspecting each item in this list, we can see a thumbnail, and in the name column, we also see component type, part number, and the latest revision level, all in a tightly grouped cluster. This keeps you from needing to scan across columns for this crucial information as you scan down a long list of components like this. Additionally, we also do have standard columns for description, part number, and revision, as each of these can be sorted to control the list order. On the right side, we have panels that are able to reveal more information about each component you select in this list. You can see a detail panel with a larger thumbnail and information like which document this component is located in. The Properties panel shows all component properties, and where used allows you to explore use cases for the component. A Revision History panel shows you release history at a snapshot and even lets you dive into the release package details if you want. We certainly are thinking about additional panels that would be useful in similar ways. Finally, you'll see that the panels refresh instantly as you select different components in the list. In addition to the panels, each component has a context menu where some actions can be found. You'll see we can launch a new browser tab that opens directly to the version of the document where this component was released. No needing to wind your way around a maze of interconnected documents to do it. Moving back to the list view and selecting multiple components and looking at the context menu reveals there are still useful actions, such as creating or adding these components to publications. For this example, I will choose to create a task, however. The task dialog launches, and I can see that the components have already been added as references to the task. I'll go ahead and fill in some details for a coworker to start looking at potential improvements or changes to these components. Useful actions on components without first needing to open documents is a win for efficiency, and we are thinking about additional similar sets of actions to accommodate. In addition to the list view, we are also working on a structure view. In this arrangement, we will reveal a related view of components to each other, as you would navigate an indented BOM or structure of a product. In a list view, this type of understanding of the data can be ascertained only after visiting many components and looking at the where used and/or contains information to understand how everything relates. In the Onshape structure view, we will do the work for you and show you all the top-level items in your view location and let you explore what is in them. Of course, an equivalent set of filtering tools and relevant actions will also be paired with a view like this. We are pleased to be working on these types of views of your company data within Onshape. We see them as a type of glue that will provide a common place for information and activities to be centered around. As always, we look forward to your feedback as we work to get these tools in your hands. Back to you, Vajrang.
Thanks, Pete. Next up is Ethan Keller from our Part Studio team. What Ethan has to show will make a lot of the sheet metal users watching very happy. All yours, Ethan.
Thanks, Vajrang. I'm Ethan Keller, and I'm a software developer here at Onshape. I'm excited to tell you about how we've been improving sheet metal with these two new key enhancements. The first is to support countersunk and counterbore holes, which will open up all sorts of new hole geometries. When you create a countersunk hole, the sheet metal part will now correctly show the countersink in the metal. For instance, this hard drive enclosure needs some countersunk holes in order to sit flat. We can use the hole feature to specify that we want a hole that will fit this M3 screw. The feature will automatically create the countersink in the sheet metal model itself. The countersunk hole also shows up right in the flat pattern as expected. You can then modify elements of the pattern based on the hole geometry. Most importantly, your model can now actually look like the as-built part. Switching over to the Assembly tab, we can use a piece of standard content that expects a countersink, such as this M3 bolt, without any interference. Now just replicate the bolt across all similar holes, and voila! Our enclosure is screwed on tight. And finally, the hole geometry, along with all the expected metadata, will be present in the drawing. This allows you to use countersunk holes in sheet metal in the exact same way Onshape already supports simple through holes. Our next enhancement is the sheet metal loft feature, which will let you bridge selected profiles to create new parts, such as duct fittings and other transitions. For instance, determining the bend lines for a rectangular to circular fitting, such as this, will only take a selection of 2 corresponding profiles and the pair of vertices through which to rip the model. Sheet metal loft automatically identifies an optimal bend strategy that approximates the desired curves. The resultant loft will be composed of triangular and quadrilateral facets, ensuring that no matter the complexity of the profiles, a corresponding flat pattern will exist. Here, we can control the number of bends within the curved region by specifying a maximum chord length. Alternatively, you could specify a maximum angle between facets or distance from underlying profile, or even the desired number of facets directly. The resultant bend lines will show up in your flat pattern, allowing you to visualize even the most complex transitions. After creating a sheet metal loft, you'll be able to modify the geometry just as you would any other sheet metal part, and Onshape guarantees it can always fold back down to the flat. The sheet metal loft feature and whole feature improvements will dramatically speed up and simplify your sheet metal common workflows. So, get ready to elevate your fabrication game with these upgraded sheet metal tools, empowering precision and innovation at every bend. Back to you, Vajrang.
Thank you, Ethan. No engineer's work is ever really done until you can clearly communicate your designs to others, and often that means creating drawings. Drawings that are of high quality, follow standards, and are something that the creator is proud of. To show you what's coming to Onshape Drawings this year, I'd like to bring on Bob Miner. Bob.
Thanks, Vajrang. My name is Bob Miner, and I manage the Drawings R&D team at Onshape. Today, I will present to you some new features we are working on and plan to ship later this year. Inspection tables are a critical part of the manufacturing process for companies. In our inspection tables, we've added columns for upper and lower limits. This makes it easier to do inspections and is standard for many companies. We are also adding a side panel to drawings for inspection tables. As you add dimensions to your drawing, new rows will be added in this table automatically. When you add inspection symbols, they will automatically be numbered and moved to the top of the table. Datum targets are a way to indicate an area on a part to be used to specify a datum for that part. The X and the callout in this image show a datum target. Bolt hole circles are a critical part of many designs. You need center marks in your bolt holes that have radial and arc lines, as shown here. We plan to support both automatic and manual bolt hole circles. Fit class tolerances are a way to specify the tolerance of a shaft in its hole. Both ANSI and ISO have tables that specify the tolerances for a range of fit classes. In this image, you can see the new drop-downs that we've added, where you can choose the fit class of a dimension. Auxiliary views. We support ISO auxiliary views now, but ISO has a second style of auxiliary view that we're adding. Instead of 2 arrows, this second style has a single arrow, as shown in this image. Excluding parts from section cuts. In section views, sometimes you want to exclude one or more parts from the section cut to make the view clearer. Here I create a horizontal section cut. I exclude the crank from the cut and then place the view. You can see that the crank is not cut when I zoom in. Sketching. We recognize that sketching in drawing views is needed. We are adding sketching in several steps. Hatching with simple sketching was released recently. Here I add a simple hatched rectangle as a no paint, no touch zone on the face of my part. You can adjust the hatch spacing. The rectangle and the hatch are part of the view and move with the view. In the future, we will add support for constraints, as you have in Part Studios. Here you can see an early prototype where I add a coincident constraint and a perpendicular constraint to these two lines. I hope these demos have helped you see all the various enhancements we're making to drawings this year. Thank you. Back to you, Vajrang.
Thanks, Bob. If you haven't been blown away by all the improvements you've seen so far, hold on to your hats. Coming up next is Michael Lauer, one of Onshape's co-founders. Mike is going to take you on a journey that will please the mathematicians and industrial designers in the audience alike. All yours, Mike.
Thanks, Vajrang. Surfacing for industrial design and consumer product design has always been part of Onshape's long-term plan. Surface design involves rapid iteration on concepts, intense collaboration, and custom workflows. These are things that Onshape does very well. So it's our belief that Onshape can and will excel in this space. We've been developing more and more surfacing tools, but we have a lot left to do. Today I'm going to tell you about Boundary Surface, the latest tool in our surfacing toolbox. But first I'll quickly mention a couple of our existing surfacing features and say a bit about why we need more. Among our surfacing workhorses is the loft feature. As I'm sure many of the designers out there know, the term loft comes from the old shipbuilding practice of laying out physical templates in an honest-to-goodness loft, a great big room, and fitting a flexible piece of wood to them, that's a spline, another word you may know, and scribing out the curve that it made. The loft feature in a CAD package does exactly the digital version of that. It fits surfaces to a sequence of profiles. Guide curves and connectors and continuity conditions are all modifications on top of that fundamental algorithm. So if you have a sequence of many profiles that you want to fit a surface to, loft is just the thing. Here's a good example, an aircraft fuselage. But the further away you get from having a sequence of profiles, the more conditions you add to it, the harder the feature has to work and the more anomalies crop up, like these wrinkles near an edge of a loft. Fill does something very different. It fills holes. It's right there in the name. And it's great at filling little irregular holes. If you use it for creating large swaths of surface, well, sometimes it gives you just what you want, and sometimes it doesn't. Among the issues that you may run into is that fill can generate a trimmed patch. That is, unlike loft or the boundary surface you're about to see, the underlying surface is not aligned with the boundary curves, which can lead to quality issues at the boundaries. And now for boundary surface. You can look at boundary surface as something akin to a symmetrical loft or a larger scale fill. Its job is to fit a high-quality surface to a four-sided boundary. Superficially, it looks like loft. Its inputs are two sets of profiles, like loft's profiles and guide curves. But internally, it works completely differently. For one thing, the two sets of profiles are treated identically. If you switch a loft's profiles and guides, you can get something very different. If you switch a boundary surface's U and V profiles, you get the same surface. Boundary surface tries to distribute the effects of boundary constraints nicely throughout its domain to produce high-quality surfaces. In most cases, the effect of, say, a tangent constraint is not bunched up at the edge, as you can see with attempts at using loft. Boundary surface tries to avoid making tight creases that technically satisfy the mathematical constraint but not the designer's intent. Although boundary surface currently supports only tangent constraints at its boundaries, if the boundary curves and bordering surfaces are well behaved, it can often give you surfaces that are very nearly curvature continuous. When boundary curves are exact B-splines or Bezier curves, curves you may have painstakingly sketched and constrained, boundary surface uses them exactly rather than approximating them by cubics, producing higher-order surfaces that have smooth curvature profiles, as you can see from the curvature combs of a boundary surface and of a loft. Boundary Surface also tries to create surfaces with relatively even and sparse control point grids. It uses as many control points as it needs to, but tries not to use more. So the surfaces it produces can be less wrinkly and more stable for downstream operations than ones with very dense grids. Here you're seeing the control points of a boundary surface on the bottom and a loft on the top. If you've been keeping up with what's new in Onshape, you'll know that I'm not really giving you a sneak peek. I'm showing you what's already there. Boundary Surface shipped a few weeks ago in release 159, but that's only the first release, and there will be a lot more coming over the next year. We'll be adding some things that you probably expect: internal profiles, connectors, and curvature continuity matching. In fact, I can show you a preview of curvature continuity right now. Here's a very simple example. You can see that as I turn on Match Curvature, the curvature combs line up. And here's something slightly more realistic. I'll turn on Curvature Color Map Display so you can see the discontinuities with tangent matching and the lack of discontinuities with curvature matching. But more than these things, we expect Boundary Surface to evolve into a more general surfacing platform. And I want to stress that Boundary Surface is just one part of our strategy. We have released and will continue to release not just surface creation tools like Boundary Surface, but other features and enhancements that are necessary for good surface design and that reduce the complexity and the number of features that you need. If you're creating surfaces from curves, your surface is only going to be as good as the curves that went into it. So we released Sketch Bezier curves and intersection curves last August, and enhanced bridging curves in December. It's important to see how good, or bad, your surfaces are, so we're adding more diagnostics. Curvature color maps and control point display just went in. Edge dihedral analysis is in the works. I hope this gives you a taste of what we've done and what's to come in Onshape surfacing. I look forward to seeing what you create with it.
Thank you very much, Mike. All these fantastic enhancements in surfacing and industrial design must have got you thinking about Render Studio, our cloud-native photorealistic rendering application built right into Onshape. To show you what's coming in Render Studio, please welcome Paul Arden, joining us all the way from Melbourne, Australia.
Thanks, Vajrang.
Paul.
If you haven't already used Render Studio, it's a fast, easy-to-use photorealistic renderer built right into Onshape. It uses best-in-class, physically-based rendering techniques to produce stunning results like these. We introduced Render Studio as a beta a little over a year ago and have been getting great feedback from our users. As you can see, they're already using it to produce amazing images of their products. I want to share with you some improvements we're working on to make Render Studio even better. We're focused on three main areas. Getting Part Studio and assembly data into Render Studio is getting a big boost in performance and reliability. Versions, merging, branching, and sharing will all start to work exactly as they do in Onshape, with everything being stored in the Onshape document model. This means there'll be no more save button. And the user experience is getting a lot of tweaks to bring it more in line with what you'd expect from the rest of Onshape. I want to give you a demonstration of our progress and what you can look forward to. Keep in mind that this is an internal demonstration version, so existing functionality might not be shown. The first thing you'll notice when adding a Render Studio is that the scene list is gone. Each Render Studio scene gets its own tab, just like Part Studios and Assemblies. You can organize them into folders and treat them like any other tab. This is a new scene, so there's nothing in it yet. Let's add a Part Studio. Notice there's no explicit conversion or tessellation step. There are default tessellation settings, and you can dynamically increase or decrease tessellation for each part at any time. The new tessellation system is also much faster and more reliable. Our part is in and rendering. We can navigate around just like before and make changes. I'll make a small change to the tone mapping settings, turning on the vignetting. And another change to the field of view. Let's make it 45 degrees. Everything I've done so far has already been saved. I could close the browser window now and not lose any work. If we expand the Onshape versions and history panel and show the changes which have been recorded, we can see the edits we just made. Since everything is stored natively in Onshape, we can go further and use its version control. I can create a version and then continue working on the scene. Let's change some more tone mapping settings. I'll open up the aperture a little to make things brighter. Now, if we want to make a branch workspace, we can select the version we made earlier and create a branch from it. If we check the box to open the new workspace, the branch will be opened right after it has been created. We are now making changes in a branch and working independently from the main workspace. Notice the bottle is a little darker since this branch was made from a version before I made the scene brighter. Let's keep working. I've decided I'd like to go for a muted black and white look, so in the tone mapping settings, I'll drop the saturation to 0.2. The vignetting could also be a bit stronger. I'll increase that to 20. Now try and keep in mind the changes I've just made. Switching back to the main workspace, you can see that these changes are not there yet. To incorporate the changes we made in our branch into the main workspace, we can use the normal Onshape merge process. You can see we have changes in both the main and branch workspace. Using the merge changes from both merge strategy, we'll combine these together. Onshape performs the merge for us, and afterwards, if we open the tone mapping settings again, we can see the changes to the aperture from the main workspace, as well as the saturation and vignetting changes from the branch are here. Of course, rolling back and restoring all work just as you'd expect as well. Undo and redo are also based on this work and generate history exactly like Onshape. Sharing is coming to Render Studio as well. Previously, if you shared your document, others would not see your scenes. Moving to native Onshape document storage allows us to address this too. So if we hit the share button and share the document with another user, I can switch over to that account and load the same Render Studio scene. Of course, I can also edit the scene, and with the new merging capabilities, users can work in a branch and then you can merge back in their changes. This may be very familiar to experienced Onshape users, but we're glad to be finally bringing this functionality to Render Studio. To close, I just want to show you a little of what the new Render Studio interface will look like. We've worked closely with the user experience team to greatly improve the consistency with the rest of your Onshape experience. As you can see, it's not a big departure from where we are now, so you'll still be able to find your way around things if you've been using Render Studio already. There are, however, a lot of quality of life improvements, like a newly organized appearance library, improved scene tree, selection process, and much more. That's a small taste of what's coming. We can't wait to get this into your hands. Thank you, and I'll hand it back to Vajrang.
Thank you, Paul. And that about wraps up our demos for today. What you've seen is just a small portion of everything we're working on. There are many more improvements coming to Onshape this year, and I would like to thank all my colleagues in Onshape who worked tirelessly in getting all these product releases out to you. Now, let's bring back the presenters once again, and we can take some questions. First question for Jake. Who will have access to Cam Studio when it's released?
Great question, Vajrang. When it's released, Cam Studio will be available for professional, enterprise, and education enterprise users.
Thank you. Question for Pete. Will there be a general search that works with the list and structure view in case someone does not know what property to look within?
Yes, we do have plans to offer a general search for these views. I didn't show that in my demo today. This likely won't be with the initial release. Also, what I didn't show in the demo today was filters in the initial release will have an ability to do some light searching that will help pare down results even finer. So for an example, if you wanted to find shafts in a list view, you could add a description filter, search for shafts, and we return on matches for that case.
Thanks. Next question is for Ethan. Will I be able to add flanges after I make a sheet metal loft?
Yes, absolutely. Sheet metal loft creates perfectly normal sheet metal parts that you'll be able to modify in all the ways that you're already used to. This also allows you to turn the selected bends from the loft operation into rips and vice versa.
Thanks, Ethan. Question for Bob. Do you plan to support linear patterns in addition to circular patterns in drawings?
Great question. Yes, we do. We're doing circular patterns, also known as bolt hole patterns, first, because that's the more common case that our customers have asked for. But linear patterns will be done right after that.
One more question for Bob. Can you export the inspection table in a .csv format?
Yes, you can. Yeah, actually, I think that's been part of the product for a while. So yes, you certainly can. Just one more comment about that too. We recognize that people want to customize the columns in an inspection report in the table, and that's being added now too. So you'll be able to specify which columns are there and what the order of the columns is.
Excellent. Question from Mike. Can boundary surface use NURBS curves? And does it make a rational surface?
Thanks, Vajrang. Right now, boundary surface only makes polynomial B-spline surfaces, and so it approximates rational boundary curves with polynomial curves, but directly using the rational NURBS curves and making rational surfaces is very much on our list of things to do.
Excellent. Question for Paul. Could other users open and edit a render studio created by another user?
Absolutely, yes. In the initial version, they won't be able to edit it at the same time, but they will be able to open it and edit it independently, similar to what happens with drawings at the moment. But later on, we are working on supporting collaboration in the future.
Great. Question for Ethan. Any plan for adding formed features to sheet metal now that the ability to show faces not part of the two sides of the sheet?
So the question is, can you repeat that one more time?
Sure. Are there any plans for adding formed features to sheet metal now that the ability to show faces are not part of the two sides of the sheet?
That is, I'm not sure what the current plan is. We'll have to get back to you on that.
All right, let's move on. We'll go to a different question. Is there a thickness or size limit for the sheet metal loft for heavier and larger parts, for example?
Yes, there will be no such size limit imposed from the loft operation. However, the geometry due to the size may fail, but there is no inherent limit on the thickness.
Great, thank you.
Thanks, Vajrang.
Question for Pete. Does my company need to have release management turned on and my documents seeded with release data to see components in the list and structure view?
Yes, another good question. Initially, this will be the case. Release data is often the most critical information, specifically the latest released information that a company wants all their users to easily see. So that's our focus for now. However, we are looking at non-released cases, and I showed a little bit of that today with the type filter where you could see a pending option there. So we're thinking about more of those cases as well. Excellent.
There's actually a follow-up question to that. How much do these updates to product structure view extend to BOMs, bill of materials?
Yeah, so it's not exactly BOMs, it's analogous, but we do expect a pairing of a BOM panel. And I hinted and suggested at some other things we may be adding. So you could imagine once you come across an assembly, there would be a BOM panel, and you could look specifically at its BOM and do BOM-related activities there. Perhaps change the template of how you're viewing the BOM or the BOM view.
Right. One more back to Ethan. Seems like there's a lot of sheet metal questions today. Along with countersunk and counter boreholes, are there plans to add other 3D elements to sheet metal?
Glad you asked, Vajrang. The changes made to support countersunk and counterbore holes were done actually with the idea of adding other 3D elements like bosses and other screw relief types. So those were already in mind. So depending on customer feedback, and no promises here, we may add support for such things in the future. Back to you, Vajrang.
Okay, great. Next one is for Paul for Render Studio. Will updates in Render Studio work?
Yes, they will. It'll be pretty similar to what you have in assemblies now for other elements. So when you've inserted an element, you can update it to a specific version and so on. We haven't worked out the exact user experience for that yet, but it should be pretty similar to what people are used to.
One more for you. Will Render Studios be viewable when shared with view only in the future?
They will, but for the user to view it, they will need to have access to Render Studio in general. So it will only be for users who would normally have access to Render Studio.
Yep, makes sense. Thank you. One for Jake for Cam Studio. Will you have a list of machines available when Cam Studio is released?
Glad you asked, Vajrang. Yes, we will. We'll have a preset library of some of the most common machinery inside of Cam Studio upon its release. And then as we continue to update the product, we'll add more and more into there.
Excellent. One for Bob. Can you select a dimension in the inspection table flyout and have the drawing view refocus on the dimension locations?
That's actually a very good question. We are doing that now, as a matter of fact, and the hope is that you'll be able to go both ways, that you'll be able to highlight from the table to the drawing and then also from the drawing to the table. We recognize that that's a nice thing to have. It just makes it all very, very clear.
Excellent. And I think we have time for one final question. This is for Paul. Is it possible to import custom appearances on Render Studio?
So I'm not sure whether the person is asking about appearances from outside Render Studio or other appearances from inside Render Studio. For inside Render Studio, we do plan to support that from other Render Studios in the future. For outside, we'd be very interested in what kind of format you might be interested in. So if they could reach out to us, that'd be good to hear.
Excellent, thank you. Well, that's about all the time we have today. So thank you, presenters, for that sneak peek and answering questions from our audience.
Thanks.
Thank you.
Thank you.
And thank you all for being part of the Onshape community and being here today. Hearing what's on your mind really helps us in our quest for continuously improving Onshape. Now, back to you, Loretta.